Nuclear power plants like these provide 20% of America's energy. But there's been very little new construction in recent decades because the technology is costly and politically unpopular. Reactors generate radioactive waste and raise fears of Fukushima and 3 Mile Island.
Evacuation.
A large amount of radioactive xenon gas had been released into the atmosphere from the auxiliary building of reactor number 2 at the 3 Mile Island nuclear generating plant.
In France, the world's largest science experiment aims to harness the power of nuclear energy in a completely different way. Scientists believe that nuclear fusion could someday provide clean energy without the fear of dangerous meltdowns or proliferation. I'm here with Mike Mauel, a Columbia professor and one of the scientists seeking to answer the call for clean energy by pursuing nuclear fusion. Thanks for coming, Mike.
Thank you very much, Chandra.
So your research is in nuclear fusion. Can you explain to me in simple terms what exactly that is?
Nuclear fusion is the energy that powers the sun and stars. It takes hydrogen gas, heating it up to millions of degrees, and brings the atoms together to release energy and make helium.
Now, what's the difference between the way fusion energy works and what we understand to be nuclear energy?
Fusion's a sort of nuclear power, but it's not the same that we're doing in the nuclear plants that we find in the world today. Today's nuclear plants split uranium and releases energy when those atoms split. What we do is we take the atoms and we put them together. We fuse them to make something else. So we take light elements, like protons or deuterium, and move them together to make helium. And it takes a tremendous amount of pressure to bring those atoms together, and energy to bring those atoms together in order to make them fuse.
Your research is connected to a project called ITER in France. Can you tell me a little bit about that?
Yes. ITER is very exciting. It's the largest experiment, science experiment in the world right now. The nations, Europe, United States, Japan, South Korea, China, and India, Russia, are all pooling their resources to build one of the first demonstrations of power production using fusion energy.
When we talk about the resources it takes to create fusion, how is that green? I mean, can you explain to me what we're using to make fusion?
The fuel for fusion basically comes from seawater. Every bottle of water that we drink has heavy water, deuterium inside, enough that's equivalent to a whole barrel of oil. So if we can take that deuterium in a bottle of water and heat it up to 200 million degrees inside of a fusion power plant, we make helium. And helium is not a pollutant. And we don't make any greenhouse gases. So it's a sustainable energy source that would last for thousands of years. And I think this is the challenge of the scientists like myself that are working in the field. How can we actually make this affordable, practical, and really demonstrate it so the world can use it as a practical energy source?
And how realistic do you think it is for us to rely on fusion energy? How would it fall into the energy mix?
That's a very good question. And I think we have trouble predicting things 5, 10 years in the future. And many people who work in fusion power look 50 to 100 years into the future. And we say, what else can provide sustainable clean energy source for thousands of years on a large scale? And fusion's one of the only ways of doing that. So fusion's going to be 25 to 50 years from now to make it commercially viable. But that's a very short time in the scheme of what we're really needing for as a sustainable planet. If we can have the technologies that are available today and allow them to be used for the next 25 to 50 years, our green technologies, our new nuclear power, our solar and wind, our natural gas, so that we can reduce the carbon footprint while we're developing the fusion power. The fusion power will be ready in the second half of the century. And I think that's when we're going to need it most.